last week, so it may look familiar. Okay, so we're going to be simplifying expressions containing 0 and negative exponents. Now you had negative exponents kind of floating around, but they always kind of went away for the most part once you added or multiplied. So we hadn't discussed it fully, but starting off with 0, and I mentioned this to you already, any non-zero number raised to the 0 power is equal to 1. It can be 10 million to the 0 power. It equals 1. Okay, that's any letter, any number. Okay, so 30 to the 0 power is 1. A fraction to the 0 power, since the 0 is outside of the parentheses, it applies to everything. Answer is 1. The one thing that most people make mistakes on, if I have negative 9 to the 0 power, it's a negative 1 because just the 9 is raised to the 0 power. So this would come out to a negative 1 versus if I had negative 9 to the 0 power, that's a positive 1 because the 0 would apply to everything in the parentheses. So this is something where a lot of people get tripped up. If that negative is not directly attached to that, it's separate because it could also be written as negative 1 times 9 to the 0. Okay. So only if there are parentheses does it apply to everything. Okay. So that's just something to look out for. So these next 3 examples have some 0 exponents in there. You still have to simplify everything you possibly can, okay, which we'll talk about in a second. What's the answer to A? 1. Okay. Does that mean you can't reduce first if you really want to, but as soon as you see that, the answer is 1, because the 0 applies to everything. Okay. Now over here, does the 0 apply to everything? No. Okay. Now if you see something raised to 0 power, it's 1, and all of these it would be like a to the 4th times 1, which you don't need. So as soon as you have a 0, I'm okay if you just kind of cross it out.
Oh yeah, you add them.
And then we have a to the 4th over a squared, which is what?
A squared.
A squared. Okay. So it might not be the entire problem like this one, but they will be mixed in to the problems. So your other rules, so this was the subtraction rule, 4 minus 2 would be 2, that still applies. Okay. Lizzie.
It's 56 divided by 8.
No, because it would be like 1a squared. The 1's there, it just doesn't have to be written. So I'm okay if you just kind of cross it out. Now, on C, for all the little zeros on the bottom, you can cross out each of those, because this would be like 8 times 1 times 1 times 1, which is still 8. Okay? So we don't need that.
I think.
What we do need to do, does 56 reduce with 8?
Yes.
What is it?
7.
7. Okay, so 56 divided by 8 is 7. Do we have any other matching variables that we need to take care of?
No.
No. So you just rewrite g squared hj to the 11th. Now, could you technically do 2 minus 0 and still get 2? Yes. Okay. H. Yeah. I need a gold pass from you. Mm-hmm. If your language happens again, I'm writing you up for it. What? Not unless I get a gold bathroom pass from you. Okay. And watch your language, please. It's the second time today I've had to warn you about that. Alright. So could we have done the top exponent minus the 0? Yes. That's why the 0 doesn't need to be there. Okay. So questions on the 0 rule. Okay. We'll zoom back out here. Now, negative exponents. Any non-zero real number can be raised to a negative power. That power is called a negative exponent. Now you cannot have negative exponents in your answers. So you're going to make them positive. Okay. Now that's if after you've combined everything, it's still negative. You've either added them, you've multiplied, you've subtracted. You have like x to the negative 2nd power. You cannot leave it negative because it's not technically simplified. So what you do, if it is in a numerator or it's a whole value, you move it to the denominator to make it positive. So if you have 3 to the negative 5th power, you take that exponent that's negative in its base and drop it to the denominator. So it'd be 1 over 3 to the 5th, and then you would find what 3 to the 5th is, which is 243. Similarly, if you have a negative on the bottom, you can make it positive, you move it up to the top to make that positive. So the negative exponents just get moved around. If they're on the bottom, you move them up to make them positive. If they're on the top, you move them down. So it's just rearranging. Okay. Now, if you have more than one m involved, maybe combine them first because it might make them positive after you combine them, which we've had up to this point. Okay. So right below this, we've already done all of these, but for your quiz at the end of the week, your answer is done when all of these occur. Okay, so all it's going to say is simplify this expression. That is done when it contains only positive exponents. Each base appears only once, so you should have one x, one y, one z, one m, one n. You should not have multiple of the same letter. Okay, so you combine them by all your rules. There are no powers of powers, meaning no parentheses with a little exponent outside of them. None of that. And then all fractions are in simplest form, meaning you've reduced the big numbers. If all that applies, then you're done. Okay. So, on the next example, D, okay, we have a to the third, b to the negative fourth, c to the negative second. We have one of each letter. So that part's done. The issue that it's not simplified is what? There's negative exponents. We need to turn those into positives. Okay. Now you can do these all at the same time. The negative 4 applies to only the b. So I'm going to take the negative 4 and its base b, and I'm going to move it to the denominator. If at the same time you want to take the c and its negative exponent and move it to the top, you can do both at the same time. So you are rearranging the problem. That's the only way to make those positive. So whatever's in the denominator, if it's negative, move it up to make it positive. If it's in the numerator and it's negative, move it down to make it positive. So just move it to the opposite spot that it's in. So your answer, the a to the third stayed because that was already positive. We have a to the third, now c to the positive second over b to the positive fourth. Now is it simplified?
Yes.
Now it is. We only have one of each letter. We don't have any big numbers to worry about. There's no parentheses. There's only positive exponents. So we're done. So a lot of times this may be a first step you do. This may be a last step you do. Okay. So it varies a little bit. But no negative exponents in your answers. You can have negative big numbers, but not negative exponents. Okay. Now a few things we can do here. Okay. First of all, does 42 reduce with 14?
Yes.
By what?
7.
Is it not
It does reduce by 7, but it also reduces by 2, and 7 times 2 would be 14. But you can reduce them in steps. Okay, so if you divide 42 by 14,
It's 3.
it is 3. Okay. So if you reduce them by 7, you would get 6 over 2, which still reduces to 3 anyway. Okay, so either way. So I'm just going to split this up kind of how I did last week, just so you can see them. So I'm putting the x's in their own fraction. I only have y to the negative 6 over 1 because there's no other y. And z to the third over z to the negative 6. Because there's a couple different ways you can approach some of these, especially when there's multiples. Okay. Now, if negative exponents freak you out, some of you, they do, and it might throw you off a little bit. What you could do first is make them all positive, then combine any variables that you have. So this would reduce by 14 to be 3 over 1. If you did not like the variables being negative, or the exponents being negative, you could move them. So I'm going to move all the ones that are negative. So this is one way to do it. I'll show you another way also that some of you would be fine with. Okay. So if I just shift these around, now I'm going to leave them in their separate fractions. Okay. So I have the 3 over 1 from the 42 over 14. I now have 1 over x squared times x squared. I have 1 over y to the 6. and I have z to the third times z to the third over 1. So I've rearranged it so now everything's positive. Benefit to doing it like this is if they're next to each other like that, you'd add their exponents. Okay. So the x's would become what?
4.
4. And what about z's? Z to the 6. Now that I've moved everything that's on the top is going to stay on the top once it's simplified. So across the top, these ones don't need to be written. So I have a 3 times z to the 6 on the top. On the bottom, what do I have? X to the 4th and y to the 6th. That's your answer regardless of the way you do it. Okay. But if they are being multiplied together, like z to the 3rd times z to the 3rd, you're going to add them. Now, some of you will be completely fine going from the beginning one, and instead you would subtract. So some of you don't have to write this down if you don't want to. The 42 divided by 14 would be 3. Negative 2 minus this 2 would be an x to the negative 4th. Now when you subtract, it always goes back to the top. So this is where it could get confusing. Y to the 6, I'm not moving yet. Y to the negative 6. The z's, 3 minus negative 3 would be a positive 6. So you could do that by subtracting first, and then move these 2 down, which would still get you here. Some of you will be okay doing that. Some of you, the negatives may freak you out. So I want to show you both ways so you can pick. And it might change depending on what the problem looks like. But if you need to reduce them all separately, make them all positive first, then combine them, do that. But if you're okay subtracting involving negatives, after you subtract, it always goes back up, and then move them back down. Okay. But if you like to move them first, then you keep them where they're at and combine. Who thinks they'd be okay just subtracting and then moving stuff later? Who would rather move stuff, make everything positive, and then combine? It's going to be a preference thing. Your answer should be the same no matter what. Okay. Questions there? So that's 2 different ways to do it. So no negative exponents in your answers. All right. Same deal. Okay. Now does 3 over negative 36 reduce? What do 3 and 36 have in common? 3. Okay. 3 divided by 3? 1. Negative 36 divided by 3? Negative 12. Okay. Does that 12 move to the top? No, it's a big number. Okay. So for instance, a lot of people will do that. They'll go, oh, 12 can't be negative. Let's just move it up. But negative 1/12 and 12 are not the same thing. Okay. So do not apply your exponent rules to your big numbers. Those are completely separate. Okay. Which is why splitting it up like I did on the previous problem might be a little bit better. Okay. But doing it this way, we'll start there. So I have negative 1/12. Okay. That negative can kind of float out in front of the fraction, or you can leave it in the denominator. It's totally up to you. With the g's, if I leave it and I don't break it up, negative 3 minus 3. Negative 6. So g to the negative 6. H to the 2nd over h was 2 minus the 1.
H.
H to the 1st. And then the j to the negative 4th is on the bottom. Okay. So this is doing it that it's a little bit faster, but there's more room for error there. Okay. So now the only thing we have left to do is this negative exponent needs to go down with the 12. This j, since it's already on the bottom, needs to move up. Okay. So can anyone tell me what the answer is?
-1 or -1 HJ4 over 2G6.
12. 6.
Yeah.
Okay. If you want to write the 1 here, nothing wrong with it. Okay. It's there either way. Okay. It throws off some people. Alright. So that's totally optional. But you should have an H and a J to the 4th on the top with a 1, whether visible or not. and then a negative, just one negative in the whole fraction, 12g to the 6th. Okay. Now again, if you didn't like that, so I'll just write them up here really quickly. Split it up. We have g to the negative third over g to the third, h squared over h, and then 1 over j to the negative fourth. Move your negatives. Okay, if the negatives freak you out. So this one reduced to negative 1/12. This would be 1 over g to the third and g to the third. This would be still h to the first, so that doesn't change because you would have to subtract. And then the j to the fourth would come up. So now the g's are already on the bottom. So if you're not sure which one goes on top or bottom, maybe move them first if they're negative. Okay. Any question on either way? So this was the two different ways right here. Let's have you guys try this one. Let's see how we do. Okay, simplify. Anyone think they have an answer? What?
35 over 14, h to the second, m to the fifth, j to the fifth, and k to the seventh.
Anything different? Marilyn?
I got 5 over 2, h to the second, j to the fifth, k to the second, and m to the fifth.
Anything different? Okay. So the only thing I was missing from you here, these two have a 7 in common, that would need to be reduced. Okay. Now the order was switched on some of those, doesn't matter, as long as the exponents match. So we were fine on the exponents, which is good. But this would be 35 divided by 7 is 5, 14 divided by 7 is a 2. So if you had checked that, 35 divided by 14 is not a whole number. So then backtrack, the next highest factor would be 7. See if that goes into both. So to get here, easiest route would be to get rid of this h to the 0 power, because that's a 1. Now you can reduce this here. So it's become 5 over 2. The h to the second stays on the bottom because there's no other h now that we've dealt with that. There's nothing else to combine. The only other issue is these two. You need to move them down here. Okay. In no particular order. So the 5 from the 35 is the only thing left on top. We have a 2, an h squared, m to the 5th, a j to the 5th, and a k squared. So as long as you have all of that, the order on the bottom, as long as the big 2 is first, I don't care about. So really all we had to do there was reduce the big numbers, get rid of the 0, and move the negative exponents. Questions before we do the last problem? Okay. All right. A population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the power of W, where W is the number of weeks after the population was measured, Evaluate the expression for w equals -2, w equals 0, and w equals 1. What does each value of the expression represent in the situation? Now, when it says evaluate, that means plug that number in where the variable is and simplify it all the way down. Okay. So we're going to have three different things here. So w equals -2 first. Okay. So plug in -2 where the w is in this function up here. So we have 5400 times 3 to the -2nd power. Now that -2, does it apply to the whole expression or just the 3?
Just the 3.
Just the 3. So to figure this out, you do need to make that exponent positive by doing what?
Moving it down.
Moving it to the denominator. Okay. Now if you want to make it as simple as possible, move it underneath the 5400. So 5400 has a positive exponent, leave it there. And now there would be a 3 squared on the bottom. Okay. What is 3 squared? 9. So here's where you would start simplifying. So 3 squared is 9. This is where you probably want a calculator. Some of you might be able to do this in your head. Plus 5400 divided by 9. 600. Okay. Now in the last sentence it says tell what each value represents. We're going to just find all three and then we'll talk about that. Okay. So negative exponent, drop to the denominator, then simplify from there. Okay. Now 0 is our next w value. So that'd be 5400 times 3 to the 0 power.
Is that just 5400 times 1?
So since 3 to the 0 power is 1, 5400 times 1 is what?
5400.
Just 5400. Okay. Again, we're going to talk about what 600, 5400, and then the next one will mean. And then we plug in a 1. $5,400 times 3 to the first power. Does that 1 need to be written there?
Yes.
No.
What's 3 to the first power? It's just 3. So 5,400 times 3.
16,200.
So first power, you write it, it's there regardless. Okay. So this kind of combined all three things that we've done so far with big numbers. Negative exponents, you can't even evaluate it till it's moved, so make sure to move it. Okay. Now, we're going to talk about what does each value of the expression represent. So we need to figure out what 600 even means in this problem, what 5,400 means, and what 16,200 means. What does W stand for?
Number of weeks
Be more specific.
after the population was
After the population was measured. Okay.
So you die.
So -2 weeks. What is that?
2 weeks
2
ago?
weeks before.
2 weeks before they measured it. Now, is that going to be completely accurate? They didn't measure it, so they don't know. But that's the estimated population prior to them measuring it. So just on your paper somewhere. So 600 represents the population, or you can write likely population too. 2 weeks before they measured it. What about week 0? The week they measured it, which means the population was 5,400. Now, once we get into starting at the end of the week and working in the next week, we're going to be talking about exponential functions, and that's where the variable is in the exponent. So the number out front that's not attached to the exponent is whatever the situation starts at. So this would be 5,400 is your starting population when they measured it. When they measured, which would mean 1 is what? That'd be 1 week after, so 16,000. 16,200 would be 1 week, so the population specifically. Can't spell population. 1 week after it was initially measured. So that means whatever insects these are, multiply very quickly. Ants, fruit flies.
Yeah.
Oh. Now we're going to get into a lot of exponential functions, again starting Friday, and then working into next week we're going to talk about exponential functions. I should come up with an example starting about the initial spread of COVID. Do you guys remember watching the news and it was like having these huge spikes?
Yeah.
Because it was increasing so fast. That's a type of these. Okay? Because it went from 600, 5,400 to 16,000, it's jumping bigger because it's increasing faster. So that's the type of functions we're going to be getting into. Non-linear, it's going to curve. So when they were trying to flatten the curve for those 2 weeks initially, they were trying to get it to stop. Just kept going for a while. Okay. Maybe I'll try and find the problem like that. Okay. But any questions about negative exponents or zero? Again, your quiz at the end of the week, it's going to just say simplify particular problems. It's done when all of these are satisfied. Okay? Questions? All right, your assignment is over there.